Our next presenter is Chen, all about the balance, GABAA receptor and epilepsy.
Have you ever thought about not being able to drive to work, swim in a pool, or play sports with friends? These are all everyday activities that seem very normal to us. But for individuals with epilepsy, even the simplest tasks can feel like they're just out of reach. For example, driving is not an option until seizures are well controlled because a seizure during driving can lead to severe accidents. And currently, over 65 million of people worldwide are living with epilepsy, including 5 million children. And epilepsy can start as early as infancy and continue throughout teenage years. Some of the epilepsy have a genetic basis, meaning that they're caused by mutations in genes that affect brain functions. What are mutations? Well, mutations are a typo in a recipe, you would think. If one of the key ingredients is changed, that might affect the final dish. So in our case, it's a protein. And a lot of genes are associated with epilepsy, one of them being the GABA-A receptors. So in my research, I focus specifically on mutations in GABA-A receptor that are known to be associated with epilepsy and how these mutations might affect how the brain functions. And what we also know is that normal brain activity relies on a balance between excitation and inhibition. So think of it as a counteraction between caffeine and alcohol. Caffeine energizes and stimulates, while alcohol relaxes and calms. But GABA receptors are known to be the brain's calming gate, meaning that they control the inhibitory signal to counteract the excitatory ones. However, when there are mutations happening in GABA-A receptor, you can lead to a loss of this inhibition, leading to too much excitation signals, ultimately causing abnormal brain waves as well as seizures. So what we also found in our research is that mutations in GABA-A receptor can result in a loss of the receptor at the nerve terminal, basically at the tip of the nerve cell where they receive message from the nearby nerve cell. So then this leads to a very important question. Knowing this information, how can we restore the level of the receptor, so thereby hopefully the activity of the receptor? So currently we are exploring drugs that can help to increase the level of the receptor at the nerve terminal where it's supposed to be, so hopefully it can do its job. And I hope that ultimately with my research, we can help pave the way for designing new therapeutic strategies for patients who are suffering from epilepsy as well as other neurological disorders, and ultimately improving patient outcomes. Thank you.